All right, you're welcome again for lesson lesson 8 of trigonometry. We are moving with it slowly. Please begin by subscribing. I told you the subscription is a token of appreciation. Keep this work going. Okay. Now, lesson 8, we are going to look at compound angle identities. Compound angle identities. Please, if you have any question, you can reach me on WhatsApp, or for any consultation, you can reach me on WhatsApp. Okay, good. So we have the compound angle identities, and we're going to see how best we can use them. All right, good. Now let's start with this. These are more like expansions. Like, how can we expand this? These are standard proofs. So now this one is, okay, when to expand sine A plus B, you say sine A cos B plus, because you have here plus, again, cos A sin B. You just keep altering sin A cos B plus cos A sin B. Then same way here. Now here I'll just copy and paste. It is sin A cos B. Now if you have a minus, you as well put the minus cos A sin B. As simple as that. When you come to this expansion of cos, now cos is a bit unique. With the cos, we have cos A cos B. It maintains. Then minus. Now, when you have here plus, you put a minus here. You must put that into consideration. Sin A, sin B. Then this one shall have a cos A, maintain the order, cos B. Now, when you have here a minus, here you put there a plus. There is some uniqueness in this cos. Then plus sin A, sin B, like that. Finally, here we are. We have a tan A plus B. How do you expand it? Please, these are things you have to memorize and cram them. Cram them and make sure they are part of you. Now, some of these formulas are provided in the logbook, so no worries. However, though, you must as well have them in your mind. Okay, now this one is tan A plus B. This one gives us a tan A plus tan B over a 1 minus tan A tan B. That's how we expand that proof. Lastly, this. Now, when you have a plus, down here you put a minus. Now, for this we have a minus. It means it's going to be a plus. Then you have a plus, maintain a plus here. So this one will be also that tan A plus, rather, it's a minus, minus tan B over a 1. Now here you have a minus, I'll put a plus. Tan A, tan B. As simple as that. So these are the expansions we use in Pythagoras theorem. So it means that you must keep in mind the Pythagoras theorem must be in your mind. Then also the compound angle identities. You're growing slowly. And I told you that trigonometry, they set one number in A, one number in B. Those are assured 17 marks. You like it or not. If you're in senior 6 right now, a must, you will do 2 questions on this part. One in A, one in B. If you're in senior 5, it is a must. You will do something on this. Okay, now, recall. Now we have this triangle. We have this triangle which has here 45. Then you have 1, 1. So here you have root 2. This root 2 was got from 1 squared plus 1 squared. We want to get this unknown. 1 squared plus 1 squared get 2. Now we need to put a square root to get root 2. Okay. Now let's read off. What is the sine of 45? Those are special. We call them special angles. Special angles we have, in the special angles we have 45, we have 60, then we have 30. Those are some of the special angles. So these are also special angles. And now, with these special angles, it means that their sine, cos, and tan are known. Okay, so now sine 45, how do you get sine 45? Opposite is 1 over hypotenuse, which is root 2. So sine of 45 is 1 over root 2. How about cos of 45? Cos of 45 is adjacent over hypotenuse. Now I think that the sine of 45 and cos of 45, they are equal. It comes from there. Now, how about tan 45? Tan 45 is opposite, which is 1, over adjacent, which is 1. That explains why when you press on your calculator, a tan of 45 will just give you a 1, because 1 divided by 1 gives you a 1. Okay, next, We also have this equilateral triangle, an equilateral triangle, which had sides 2, 2, 2 units. This plus this gives you 2. But I've divided it in the middle to bring in this other special angle, which is 30. To say that that's why this one is 1 and 1. All right, good. Now, using the angle of 60, let's begin using the angle of 60 on this triangle. Please, you must be knowing this triangle in your mind. You cram it. So, let's get sine of 60. Sine of 60. All right. So, sine of 60 here. If I try to cover, if I cover here, which now when you try to use the algebra, if you have here 1, 2, this side here will be root 3. That height will be root 3. Put that into consideration. So sine of 60, I'm now using this triangle here like this. That triangle. But remember, this one is root 3. So sine of 60 means opposite. Opposite, which is root 3, over hypotenuse, which is 2. There we are. That is the sine of 60. How about cos of 60? Cos of 60 is adjacent, which is 1. Then hypotenuse, which is 2. So cos of 60 is a half, by the way. Tan of 60. Tan of 60 is opposite, which is root 3, over adjacent, which is 1. That explains why tan of 60 is the same as root 3. You can take it as that. This one here. The same as root 3. All right, good. Now let's go about getting the sine of 30. Let's go in 30s. So sine of 30, I'm not using this angle. Now using this angle, this is the opposite. This is the opposite. The root 3 is the adjacent. This root 3 is the adjacent. This is the opposite. This is the adjacent. This is the longest side. So sine of 30 is opposite, which is 1. Opposite, which is 1, over the hypotenuse, which is 2. How about cos of 30? Cos of 30 is adjacent, which is root 3, over hypotenuse, which is 2. Okay, now tan of 30. Tan of 30 is opposite, which is a 1, over adjacent, which is a root 3. So those are now our special angles which you shall be using. Please, where necessary, cram this as a student of mathematics. You must be knowing all this, and the whole graph comes from this. You can just cram this triangle. 60, 60, 30, 30, 2, 2, 1, 1, root 3. Even this one, like that. So let's now go to example 1. They are saying, find the values of the following, comma, leaving your answer in SAD form. Find the values of the following, comma, leaving your answer in SAD form. All right. Leaving your answer in SAD form. Now, SAD form means these are SADs and the root and the root. So mean that we're going to be using these ones here. All right. Good. Now, remember number 1, we have part A, we have sine of 15. Now remember, we must use this logic to get this done. Sine of 15. We shall, without using calculator, so what we're going to do, shall say, in our solution, we shall say. Now we must say that, okay, solution. In our solution, we shall say that a sine of 15 is the same as sine of what? Say, for example. Now, you come back to the special angles, of course, the ones which you have in these triangles. You come back to the special angles, look out for the 2 angles here, which when you add or subtract, the final result you get is a 15 among these ones. And you see that to get a 15, we can have 45 minus 30. So that this minus this gives me a 15. So you must look out for the special angles which can do add or subtract and gives you a 15. I'm seeing now this magic coming out. Now that means that we shall say now from, shall say, okay, I'll use this area. I'll now say from, since I've seen a minus, from now a sine of A minus B is equal to sine A cos B minus cos A sine B. So now let's substitute. Whatever I bring this guy, I come and put him there. Sine 45 minus 30. This will be, now, the A is 45, the B is 30. So that will be sine of 45, okay, times a cos of 30 minus a cos of 45 times a sine of 30. That's what you do. The next, we are going to substitute in. Now, what is sine of 45 there? Sine of 45 is same as 1 over root 2 times, we are applying cos of 30. Cos of 30 from this area here, cos of 30 is root 3 over 2. Root 3 over 2. Please, this is a multiplication. That dot means a multiplication in pure mathematics. Minus a cos of 45, still 1 over root 2 times sine of 30 is 1 over 2. You can cross check from there. Okay. Now this will give us, when you multiply, you'll get root 3 over 2 root 2 plus, rather, it's a minus, minus 1 over 2 root 2, like that. So it will now be our final answer. Can we leave it as that? You can simplify this. Okay. This will be, can we leave it as that? No problem. After all, it's not a proof. So that's our final answer. We can leave it in sad form. Or if you want, you can get the LCM here and you'll go about simplifying, but even that is okay. Next, we have cos of negative 15. Cos of negative 15. Cos of negative 15 here. So in that, a cos of negative 15, how did this one come about? Which numbers do we, from these special angles, which of the two special angles do we add or subtract and we get negative 15? We realize that one here is a reverse of, so for example, we shall have cos of, what is separate? Be now 30 minus 30 minus a 45. You see that this minus this gives you that. And that will imply that you're going to use those identities there. So we're going to say these are degrees. We are going to say, okay, continuing from this side, this will now be cos of A minus B is equal to a cos of A cos of B minus sine of A sine of B. Oh, we have a minus, this becomes a plus. So this will now be, all right, bring this now, and that will be a cos of 30 minus 45. That will now be, okay, this is a cos of 30 dot a cos of 45 plus a sine of 30 dot a sine of 45. Next, they said you have your answer in sad form. So you substitute. What is the cos of 30? Cos of 30 is root 3 over 2 dot. What is cos of 45? Is 1 over root 2 plus sine of 30 is a half times sine of 45 is 1 over a root of 2. So this one will now give us root 3, because root 3 times 1 gives you root 3 over 2 root 2. A 2 times root 2 gives you 2 root 2, not root 4, plus 1 times 1 will give us a 1 over 2 root 2. As simple as that. Okay, the last one is here. We have a sine of 75. A sine of 75. Now, two numbers that you add, you get that. So, I will say sine of 75 is equal to a sine. Now, what do we do here? What do we do? I think, do we add or subtract? You see that? When you add this plus this, the 45 plus 30. So, 45 degrees plus 30 can now give you the 75. Okay, now with this one I'm leaving it for you such that you also complete up. I'll be leaving it at that level such that you also come and complete up and give us that answer. So you have seen how important this is, but don't forget, please. All right, so we have another example. Example 2, still about lesson 8, compound angle identities. If sine A is equal to 3 over 5 and sine B is equal to 5 over 13, where A and B are acute angles, first of find the values of Roman number 1, sine A plus B, then Roman number 2, tan A minus B, and Roman number 3 is sec A minus B. All right, good. So let's now handle this. Now we have sine A is this and it's acute. So what you're going to do, we shall now say solution. In our solution, we shall say, let's begin by expanding this guy. So this one will be that a sine of A plus B. Expand from the identities we have. This will be sine A cos B plus cos A sine B. That's the expansion we can have. Now, as per this expansion, you realize that we need a sine of A. Do you have sine of A? Yeah, good. Like we are. We need the cos of B. Do you have cos of B? No, we don't have. We need the cos of A. Do you have it? No. We need the sine of B. We have that. So mean that we have sine of A, we have sine of B, but we don't have cos of B and cos of A. How shall we get them? We start from this. We come and say now, from sine A, which is equal to a 3 over 5. But from SOHCAHTOA, this is opposite. This is hypotenuse. Then this will mean that you have to get this triangle already there. Now, the sine of A, the angle here is what we put here, like that. Now, our opposite is 3, and our hypotenuse is 5. Now, we need this other counterpart. That counterpart, I will call him x, and then it will be that x squared plus 3 squared is equal to a 5 squared. So this will be x squared is equal to a 5 squared minus a 3 squared. I've brought it like terms. So x squared will be the same as 25 minus 9. That will be 16. So square root of x. So your x is equal to 4. So therefore this part has what? 4. Now what we must do, what do we need? We need a cos of that. But therefore what I'm going to do, I will say, I'll read off a cos of A from there. Cos is SOHCAHTOA. Cos is adjacent hypotenuse. So adjacent is 4 over hypotenuse, which is 5, comma. Let me also read off the tan. Tan of A. Tan of A will be what? Opposite, which is 3, over adjacent, which is 4, like that. Then, I want to see whether I put a negative or not. They are in which quadrant? They are acute. And in in the acute, it means it is like this. I'll rub it away. Acute means this. This was acute. You can remember that. This one was obtuse. And this was reflex. So, from 0 to 90, here they are all positive. So, it is positive, positive. Like we are. Then also, I must come and get the one for sine B. Also from sine B is equal to a 5 over 13. This is opposite. This is hypo. Now what you're going to do, I will again draw my triangle. My opposite is 5. This is 13. I'll also need this side value here. Let me call it x again. And now that will be that x squared plus 5 squared is equal to 13 squared. Here I'm going to go direct. So x squared is equal to, you know the algebra which will be there. So this will be 13 squared. Okay. 13 squared minus 5 squared will be 144. Will be 144. Now that 144 will mean that a square root and also a square root. So this will give us that x is equal to 12. So here we have there 12. Then also here, come and read off the cos of B. Or by the way, if it is B here, you put here angle B. Cos of B is equal to, okay, opposite, that adjacent which is 12 over hypo which is 13, comma, a tan of B. Tan of B will be, all right, adjacent, opposite adjacent. So 5 over 12. Now they are all acute. They will be positive, positive. I'll leave them like that. The next what I'm going to do, I'll now come and say, now we bring that and substitute in here. So this will now be equal to sine of A cos B. Sine of A is a 3 over 5. 3 over 5, I will say times cos of B. Cos of B is 12 over 13 plus cos of A. Cos of A is here, a 4 over 5 times a sine B. Times a sine B. Sine B, which is 5 over 13. That's what we're having. And now go about simplifying. This time, this will give us 36 over 13 times 5. 13 times 5, so 13 times 5 will give us 65 plus, now 4 times 5 is 20, but over 65. So now this will be, finally, when you add, these are the same LCM, so you just add this one. So that will be now 56 over 65. Use a calculator to add that up. And you see that that will be our final answer to find sin A plus B, given that that is true. All right, let's now go to Roman number 2 without wasting time. Roman number 2, here we are. Now, we have finished to do the whole science here. All we need is just expanding. So Roman number 2 shall say solution. Roman number 2 shall say solution. So this will be that a tan of A minus B. From the identities, please, you have them. The identities, you have them. Is equal to tan A minus tan B over 1 plus tan A tan B. Here there's an application. After reaching that level, now let's substitute. What is our tan A? Tan A is 3 over 4. So tan A is 3 over 4 minus tan B. Tan B is 5 over 12. 5 over 12 over a 1 minus 3 over 4 times 5 over 12. That's what we're having. So you can use your calculator to solve the values up. Use your calculator to solve the values up. That's 3 over 4 minus 3 over 4 minus a 5 over 12. That is a third. Up we have a third over, solve down, that is 1 minus brackets, 1 minus brackets, a 15. Now 3 times 5 is 15 over 4 times 12 is 48. So I want to say 1 minus that. So 1 minus 15 over 48. That will give us 11 over 16. So 11 over 16. Now it will be our final answer here. And try to divide. So I will say 1 over 3 divided by the 11 over 16. Okay, the answer we have is 16 over 33. Please let the calculator do the work. It's better use a calculator for simplicity. So that is the answer already. Now, let's go to this. We have that sec A minus B. That's what they want us to get. Now, you all know that a sec A minus B is the same as 1 over, of course, reciprocal, 1 over cos A minus B. 1 over cos A minus B. Now, what you will do, you just go and find the cos of A minus B. So come and struggle with this. The cos of A minus B, then we'll take it back for the sec. This will be equal to a cos A cos B minus a sin A, rather plus. If it's a minus here, put a plus. Sin A sin B. So therefore, what we're going to do here is, you now come and substitute. What is cos A? Cos A, from there, cos A is 4 over 5 times, all right, cos B is a 12 over 13 plus a sine of A was 3 over 5, 3 over 5 times, sine of A is 3 over 5 times, sine of B is 5 over 13. That's what you're having. Please use your calculator. This will now be, oh, I can see. This is now 48 over 65 plus 15 over 65. What will be your final answer here when you add? They have the same denominators, so you can add just the numerators and everything will be okay. What I'm meaning is, when you have A over X plus B again over X, this means that if these ones are the same, you can just have it as X there. Then you just add these other ones up, A plus B. That's what I'm meaning, that they have the same denominators. You just add the numerators. That will now be 48 plus 15. Oh, that's a 63. So that is now a 63 over a 65, like we are. All right, now what we're going to have here, but remember, this is for cos. This is for cos A minus B. Now what about sec? Remember sec? Sec was 1 over that. So you'll say now sec A minus B. You all know that sec is a reciprocal. If cos is this, now sec will be the reverse order, a reciprocal. So that will be a 65 over a 63. Okay, and that's how simple it is. Please don't forget. All right.